Hello students, in this video we are going to look at the chapter number 6 from this book sampling and sampling distributions. So introduction to sampling. Statisticians use the word population to refer not only to people but also items that have been chosen for study. And statisticians use the word sample to describe portion chosen from the population. The table denotes various notations used. When we talk of population, we call the specifications as parameters, whereas for sample we call it statistics. Population size is capital N, sample size is small n, population mean is capital mu, and sample mean is x bar. Population variance is sigma square, not written here. Sample variance is s square. Population standard deviation is sigma. Sample standard deviation is s. Also, if you just recollect the formulae for population variance, we just find out sigma of x minus mu square upon we use total population size, and for standard deviation square root of that, right? And if it is a group data, then we use frequency to multiply x minus mu the whole square, right? So this is what we do for population. But when we are calculating for sample, and in case we need to calculate the variance and standard deviation from the given raw data of sample, then there is a small change in this formula which we are supposed to do, and it is denoted here. Instead of capital N, which is the population mean, population size, we use n minus 1. N stands for the sample size minus 1. So this minus 1 is a must. For sample variance is sigma of x minus x bar square upon n minus 1. Similarly, standard deviation is square root of that, where the denominator is n minus 1. So this has to be remembered when we start calculating sample variance and sample standard deviation from the given raw data. Now there is some theoretical aspects which are there in this chapter, which you need to study on your own. So I am recommending that you study this between the page numbers, page 278 to 290, types of sampling, various types of sampling. I will just quickly go through them quickly here, but you need to study them in detail. So there are two types of sampling. One is random sampling, other is non-random sampling. In random sampling there are again different types: simple random sampling, systematic sampling, stratified sampling, cluster sampling, and all these are explained in detail there in the book. So please go through them and also try to remember, or try to understand the examples which they are using to explain these concepts. Then there are non-random sampling, which can be convenience sampling, judgmental sampling, quota sampling, shopping mall intercept sampling, and snowball sampling. So the book also explains these 5 methods in detail along with the examples. So please go through them and try to make your own notes from that. Now let us go to the sampling distribution. So what exactly is sampling distribution? So here statistician use this sampling distribution. So a probability distribution of all possible means of samples is a distribution of sample means. Statisticians call this as a sampling distribution of the mean. So from the population, if we draw various samples, for each sample if you calculate the mean, suppose you take 50 different samples, and which almost covers the entire population. So you will have 50 means, and when we develop a distribution from these means, it is called as the probability distribution of the mean, or also called as sampling distribution of the mean. Now, what is standard error? For this sampling distribution of the mean, the standard deviation is called as the standard error. So the standard deviation of the distribution of sample means is called as the standard error of the mean, and it is given by the formula sigma x bar. I will show you that formula a bit later. Uh, so if you want to go through the sampling distribution of mean in more detail, you can clearly read this in detail, and so that you properly understand everything here. So they have given this. I even recommend you to pause the video and read from here before we go ahead. So they have explained this, that this is our population, which can be normal or non-normal. We will see those variations a bit later. And from here we are taking various samples. From every sample we are getting a mean, and those means are now used for developing a distribution, which is this. So this is called as the sampling distribution of the mean. This sampling distribution of the mean will have its own mean, which is given by mu x bar, and the standard deviation of this distribution is sigma x bar, which is standard error. And the property for this is given here. If you are sampling from normal population, that means the population itself is normal, then the mu x bar will be equal to mu, and sigma x bar will be, that is the standard error, is calculated by sigma upon root n, where n here is the sample size. So this sigma x bar and mu x bar is now used to calculate the z value. So z is, the standardized value is x bar minus mu upon sigma x bar, right? So this is the to be calculated first as sigma upon root n, and then you calculate z. Individual savings accounts which are normally distributed with a mean of $2,000 and a standard deviation of $600. If the bank takes normal sample of 100 accounts, what is the probability that the sample mean will lie between 1900 to 2050? So this is the problem, and clearly when you read the problem, you clearly get to know that it is a normally distributed population. Population mean mu is 2000, population standard deviation sigma is 600, sample size is 100n, and we need to find out that what is the probability that the sample mean will be between 1900 to 2050. So how to go about this? We need to first calculate z values at these two points. So we will start doing this. First we will have to calculate sigma x bar, which is sigma upon root n, which is 60. In this case it will come to 60. Then we use this formula and we calculate z at 1900, which will come to minus 1.67, and z at 2050, which will be equal to 0.83. Once we do that, our next step is to identify the area of our interest between these two values of z, and we can, you can even draw a rough diagram. So this is the diagram which we should develop. So if you see here in this diagram, this is z equal to 0.83, this is z equal to minus 1.67, and we can use the table the z table to calculate the value. For z equal to 0.83, this is your table. So you go for 0.8 and 3, it will be 0.2967, right? So here 0.2967 is there, minus 1.67, but we do not have minus values, we have values only positive in the table, but we know that the minus 167 area will correspond to the plus 1.67 area. So we will look for 1.67 area, 1.6 and 7, so 0.4525. So you see here 0.4525. So this area will be 0.4525. This area will be 0.2967, and we want the total area between these two, which will be 0.7492. Hence our answer is 0.7492 or 74.92%. So this is the example when we are drawing sample from normal population. Now there are variations to this which we will see in my next video. Thank you.